The matric learners of a certain high school like to vote for the chairperson of the RCL. The scatter plot below shows the IQ of the 10 learners who received the most votes and the number of votes that they received. Before the election, the popularity of each of the 10 learners was established and a popularity score was assigned to each. The popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below. Right, and then the first question, 1.1, 1.1.1. Let's calculate the mean of the number of votes that these learners received. So I'm not going to do anything manually. I'm going to calculate using my calculator. So let me go ahead and do that. I want to find the mean of the number of votes. So I'm concentrating on only one variable. I'm going to press mode setup, and then 3 for stats, 1 for one variable, right? Because I'm only interested in one variable. So the number of votes, we have 9, followed by 22, 10, 21, 11, 15, 20, 12, 19, and 16. Right, you have to verify that you've entered the correct data, because if you've not, your answers are going to be incorrect. Right, now you press equals to a couple of times and then you press AC. From there on, shift 1 and then you go to option 4, VAR. Right, and then when you press option 4, you're going to have X bar, which is the mean. So when I press 2 and equals to, I get 15.5. So that is the mean. The Y bar in this case, because the number of the votes are Y bar is equals to 15.5. You might be asking yourself, but we are only writing the answer. What about the formula or the substitution? Am I not going to lose marks? No. Even if you write only the answer, you get full marks. So you don't have to worry about that. 1.1.2, we're looking for the standard deviation of the number of votes that these learners received. So let's go ahead and find the standard deviation. We're going to press AC. Shift, we've already entered our data. We don't have to tamper with it or enter it again. So shift 1, and then we're going to choose option 4. And then now we press standard deviation, which is option 3, right? In your calculator, it might be a different option, but as long as you choose the correct option. Equals to, and I'm getting 4.59 if I round it off to 2 decimal places. So our standard deviation is equals to 4.59 rounded off to 2 decimal places. Let's go ahead and do 1.2. So in 1.2, the question is saying that the learners who received fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? So now we have to determine the value of 1 standard deviation below the mean. So we're going to have Y bar minus the standard deviation, right? This is equals to, what is the mean? 15.5. The standard deviation, 4.59. And this should be equals to 10.91. So how many learners had less than 10.91 votes? Let's go ahead and find out. So we have 1, the learners received 9 votes. 2, what else? Right, so 2 learners were not invited for the interview. So the learners that were invited, we're going to have 10 minus 2, which is equals to 8. So only 8 learners were invited. 2 learners had the votes, 1 standard deviation below the mean. That is 1.1. Let's take a look at 1.3. In 1.3, we're supposed to determine the equation of the least squares regression line for the data given in the table. How are we going to do that? AC mode 3 for stats, and now we're interested in two variables. So that is option 2, a plus bx, which is the equation of our least squares regression line. Y is equals to a plus bx. So let's go ahead and press 2 and enter our data. We're going to start with the x values. As far as the x values are concerned, we have 32, 89, 35, 30, not 32, but 82, right? 50, 59, 81, 40, 79, 65. Right, now I have to go ahead and punch in the y values. So let me go up to the first x value. So you have to punch in the y value close to its corresponding x value, right? So 39 is going with 9, 89 is going with 22, 35 with 10, 21, 11, 15, 20, 12, 19, and 16. There we go. I have my data. 16, not 17, right? The y value is 65 and the x value is 16. Right, there we go. Now I can press AC, shift 1. Instead of choosing option 4, I'm gonna choose option 5, which is regression. So in option 5, I have my variables a and b, which I need, right? So for the variable a, you press 1 and then press equals to. As you can see, a is equals to 1.77 rounded off to 2 decimal places. Let's go ahead and find b. So if I want to find b, then it is AC shift 1, well, shift 1, right, 5, and then I'm looking for b now. That is option 2. This is equals to 0.22. So b is equals to 0.22. Y is equals to 1.77 plus 0.22 x. Yeah, there we go. We have the equation of the least squares regression line. Let's go ahead and do 1.4. So 1.4, predict the number of votes that a learner with a popularity score of 72 will receive. The popularity score is the x value, so we just need to substitute it into this equation. We're going to have y being equals to 1.77 plus 0.22 multiplied by x. What is the value of x? The popularity score, 72. In your calculator, you're going to get 17.61, but we cannot have 17.61 votes. So let's just round it off to 18. So yes, if you have a popularity score of 72, you're going to get right about 18 votes. Right, let's go ahead and do 1.5.1. Use the scatter plot and the table above and provide a reason why IQ is not a good indicator for the number of votes that a learner could receive. As you can see from the scatter plot here, there's no correlation between IQ and the number of votes. This person has a very low IQ and so many votes, and this person has a very high IQ and they have a lot of votes. Even the people in the middle with average IQ, they have a lot of votes. So there isn't really a relationship between IQ and the number of votes, it seems. Right. And then, so that is why IQ is not a good indicator, because, yeah, there is a very low correlation between the IQ and the number of votes. Why is the prediction in 1.4 reliable? Well, in 1.4, we are using the popularity score to determine the number of votes that a person is going to get. That is because we have a very high correlation. Well, you can use shift 1 and go to 5 for regression and press the option that gives you the correlation coefficient. In this case, it is going to be 0.98. A very high correlation will lead to a reliable prediction. How many people are employed at this company? We are given the cumulative frequency, which is 60. So 60 people are employed at this company. That is 2.1. Let's go ahead and take a look at 2.2. Write down the model class of the data. Well, let's read through our statement and see what is happening. So a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the cumulative frequency graph below. Okay, so we're looking for the model class of the data. The model class derived from the board, it's where we have the highest frequency. So let's go ahead and take a look at that. From 5 to 10%, this is the frequency. From 10 to 15, this is the frequency. From 15 to 20, this is the frequency. And then 20 to 25, 25 to 30, 30 to 35. 20 to 25 is where we have the highest frequency. So that is our model class. 20 to 25. 2.3. How many employees spent more than 22.5% of their salary on fuel? Let's go ahead and find 22.5. This is 20. This is 25. So 22.5 should be in the middle, right? Let me just erase all this for the sake of clarity. And let me draw a line so that we can see the cumulative frequency at that point. At 22.5, we are trying to figure out the cumulative frequency, 34. So employees that spent more than 22.5% of their salary on fuel will be 60 minus 34. We have a total of 60 people. 34 people spent less than 22.5%. So people who spent more than 22.5% is 60 minus 34, which is 26 employees. So that is the number of people that are spending more than 22.5% of their salary on fuel. Right, 2.4. An employee spent 2,400 of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. So he spent 2,400 on fuel, and this is only 7% of his salary. What is his entire salary? We know fully well that if we say salary multiplied by 7%, it will give us 2,400. Right, 7% of this person's salary is spent on fuel, which is 2,400. So in order to find the salary, it's just a matter of dividing both sides by 7%. And if we do that, we're going to get 34,285.71. 2.5. The monthly salaries of these employees remains constant, and the number of liters of fuel used in each month also remains constant. So salary is constant. The liters of fuel required are constant. If the fuel price increases from 21.43 to 22.79 per liter at the beginning of the next month, how will the above cumulative frequency graph change? What is going to change is the percentage of salary spent on fuel. People are still traveling the same distance, but now the fuel costs more. So the percentage of salary spent on fuel will increase. So we would expect our cumulative frequency graph to shift to the right as we have higher percentages towards the right. Let's go ahead and calculate the gradient of AB, right? So we say that the gradient of AB will be equals to y2 minus y1 divided by x2 minus x1. So we have to decide which point we take in as point 2 and which point we take in as point 1, right? So let's take point A as point 2. So we're going to have 4 being x2 and then 2 being y2. And then here for B, we're going to have x1 and y1. So if we substitute that, for y2 we have 2, and then for y1 we have minus 4. So that will just be plus 4. And then everything divided by x2. What is x2? x2 is 4, right? And then minus x1. x1 is 6, so we have minus 6. So we have 2 plus 4, which is 6, divided by minus 2, right? And then this should be equals to minus 3, right? That should be equals to minus 3. Now let's do 3.1.2. That is saying, let's calculate the size of this angle here, right? So if we want to calculate the size of that angle, and we already have the gradient of AB, we can just say that tan of that angle will be equals to the gradient of AB, right? So that angle there will be equals to tan inverse of the gradient, which is minus 3, right? And if you put that in your calculator, you should get minus 71.557 degrees, right? If we get a negative angle, we always add 1/8, right? And then if you do that, that angle should be 108.43 degrees. And we're moving on to 3.1.3. 3.1.3 says, let's calculate the coordinates of D. We can see that T is the midpoint of CB, because CT is equals to TB, right? So we're going to use the midpoint theorem, so to say. So what are we saying? For T, using the midpoint theorem, we're going to have x2 plus x1 divided by 2, and then for the y coordinate we have y2 plus y1, everything divided by 2, right? Since we have let BB have x1 and y1 as the coordinates, let's let C have x2 and y2. So if we compute that, we're going to have the coordinates of T being minus 2 plus 6 divided by 2, and then minus 3 minus 4, right? And then divided by 2. So here we're going to have T having coordinates. So we have minus 2 plus 6 divided by 2, which will give us 2, right? And then minus 3 minus 4 divided by 2 should give us minus 7 divided by 2, right? And let's use 3.1.4. So 3.1.4 here is saying that let's determine the coordinates of S. Lucky we are given the equation of line AC, right? It's given to us here in the equation. We're given the equation for line AC. They're saying that equation we have 5x minus 6y being equals to 8, right? So we can just so S, let's look at S. You can see that the x coordinate of S then is going to be 0, right? So we can just substitute that. If we substitute that, we're going to get 5, 0 minus 6x is equals to 8. So that 5 is just going to fall away, right? So you just have y being equals to 8 divided by minus 6, right? If we divide everything by 2 there, we should get 4 divided by minus 3. So the coordinates of S is 0 and minus 4 divided by 3. Now let's do 3.2. So 3.2 here is saying that let's determine the equation of CD in the form y is equals to mx plus c. So let's go ahead and look at CD. So we have a CD here. So here's CD, right? But then is said to us that CD is parallel to AB, right? So we already know that M is equals to minus 3, because don't forget that in 3.1.1, when we calculated the gradient of AB, we got minus 3. So now we just are looking for C here, right? Of which we're gonna do by substituting our point C, right? If we substitute C of coordinates minus 2 and minus 3, we shall get Y is equals to in place of Y we put in minus 3. We're gonna have minus 3 is equals to, and then the gradient is minus 3, right? So we have minus 3, and then X is minus 2 plus C. So we have minus 3 minus 6 being equals to C, right? So minus 9 is equals to C. So equation is now Y is equals to minus 3X plus C. C is minus 9. So let me just see if that works real quick. So if we substitute minus 2 and then we minus 9, we're gonna get 6 minus 9, which is equals to minus 3. So it seems like we're on the right track here. Yeah, let's carry on and see what happens. So if we do, if we come to 3.3 here, and then 3.3.1 is saying that let's find the size of DCA. So DCA, let me just erase what we have here for a bit of clarity. So DCA is this angle here. This question is for 4 marks, right? I did spend some time thinking about this question. I don't want you to think that I just saw the question and then I jumped straight into the answer. I had to, think about a lot of things in order to answer this question that we have here. So these kind of questions, they demand a lot of thinking, right? And you should be willing to do that. But let me show you something. This size here, this angle here, A, right? This angle here should also be A, because DC is parallel to AB, right? So, and then apart from that, using CA, we can find this angle of inclination that is here, right? And then if we have that angle of inclination, we can say that this angle here is equals to DCA plus this angle here, right? An exterior angle of a triangle is equals to the sum of the two interior opposite, right? And then from there on, we can then find that angle DCA. So let me show you what I'm talking about. We're saying that angle DPO will be equals to this angle here. We calculated it. We say it is 108.43. So 108.43 degrees, right? And then we say that we need this angle because it will be equals to this angle here, and then we're gonna use exterior angle of a triangle, right? So let's calculate that angle. How are we gonna calculate it? We're gonna say that tan of theta is equals to the gradient, right? So here we're gonna say that theta is equals to tan arc of the gradient. So what are we saying? We're saying y2 minus y1 divided by x2 minus x1. But then just for the sake of time, we're just gonna do it without writing the formula down, right? So what is y2? Let's take A as our second point, right? So y2 should be 2 here, and then y1 should be minus 3, right? So that will be plus 3 because we say y2 minus y1. And then now let's look at x2 minus x1. So x1 is 4, and then x2 is minus 2, so that should be plus 2. So we're saying that theta is equals to tan inverse of 2 plus 3 divided by 6, essentially, right? And that should be equals to 39.81 degrees. So this angle, we can replace it with 31. We're replacing it with 31.81, right? So this angle here should also be equals to 39.81. I meant, yeah, what am I writing? I'm saying 39.81. Yeah, that's what the calculator says. 39.81. I don't know what I was writing there. So now we can say that angle DPO is equals to angle DCA plus angle what? Angle PFC, PFC, right? And then we're given the reason the exterior angle of a triangle is equals to two opposite interior, right? Yeah, the story goes on. So what is DPO? DPO, we know that it is 108.43, and that should be equals to DCA, which we are looking for, plus PCF, which is 39.81. So now DCA should be equals to, so we say in 108.43 minus 39.81. I'm getting 68.62 degrees. It doesn't look too bad, right? 68.62 degrees is believable. Let's do the last question. 3.32 area of POSC. So let's erase everything again and just look at POAC. So we have POSC, not AC, POSC. So let's look at POSC. Okay. I think, yeah, thought of a way. So because let's do this. Because we have this angle here, right? We know the size of that angle. We can use the side CF and the side CP to calculate the size of that of triangle PCF, right? After we have calculated the size of triangle PCF, then we can subtract triangle OFS, right? We can subtract the triangle, and then we're gonna have the size of, or the area of POSC. So let's go ahead and do that. So we're saying that we're using CP and CF, right? So let's calculate CP. Here comes the distance formula. The formula I hate more than any other. So we need the coordinates of P, right? And then we have the equation of CD, right? We calculated it in 3.2. So on the equation of CD here, if we substitute, so we're letting y be equals to 0, right? So if y is equals to 0, let's just work it out here. If y is equals to 0, then 9 should be equals to minus 3x. So x should be equals to minus 3, right? So we're saying for P, we have minus 3 and 0. And then which other one do we need? We also need the coordinates of F, right? We have the y coordinate of F is 0, and we are given the equation of AC. So let's look at the equation of AC. The equation of AC is given as 5x minus 6y is equals to 8. So what is 5x? We say in y is 0, so we're gonna have 5x being equals to 8. So x is equals to 8 divided by 5. So here let's say 8 divided by 5. Yeah, so let's go ahead and calculate CP. So CP is going to be equals to so distance formula, we say y2 minus y1 squared plus x2 minus x1 squared, right? So CP, let's let P be the second point. So if we say y2 minus y1, we're gonna get 0 plus 3 squared plus x2 and then plus 2 squared, right? So let me just compute that real quick and see what I get here. Square root of 10, right? So now let me do CF. CF is equals to so CF, let's take F as the second point. So we're gonna have y2 minus y1, so we have 0 plus 3 and then squared plus x2 minus x1, so we're gonna have 8 divided by 5 plus 2 squared, right? CF, I'm getting 4.68 69. let's say 6861. Let's not round off to 2 decimal places when we're not at the final answer, right? So now we can say that the area of triangle CPF is equals to, I have side 1, side 2, and then sine of the angle of the two sides sandwich, right? So that will be angle DCA. So the area of CPF will be square root of 10 multiplied by 4.6861 multiplied by sine of that angle. We said that angle is equals to 68.62. 68.62, and that should be equals to 6.8995 units squared, right? So now we can calculate the area of triangle OCF and subtract it from the triangle PFC to find the area of OSCP. So what are we saying now? We're saying that the area of that triangle. So let's analyze that triangle. So we can easily find the length of OF, right? And we can easily find the length of OS, and then the angle they will send, which is this one, which is 90, right? So I think that's the best way to go. So we can say that OF is equals to 8 divided by 5, right? It's easy to see. And then OS is equals to, do we have the coordinates of S? Yeah, 3.1.4. Let me look. So that will be 4 divided by 3, right? So OS is equals to 4 divided by 3. So I can say that the area of triangle Triangle OSF will be equals to a half multiplied by 8 divided by 5 multiplied by 4 divided by 3 multiplied by sine of 90, which is just 1, right? So we just have a half multiplied by 8 divided by 5 multiplied by 4 divided by 3, which is equals to 1.0667. So now we can say that the area of POSC should be equals to 6 point, this is units squared, should be equals to 6.8995 minus 1.0667, right? And that should be equals to 5.8333 units squared. Let me know what you think in the comments. Let's go ahead and calculate the coordinates of P. So we have 4.1, which is saying that let's calculate the coordinates of P. We can see fully well here that M is the midpoint of the line PN, right? So if we were looking for the x coordinate of M, we would say that XM is equals to x of n plus x of p divided by 2, right? That's what we would do. We would be applying the midpoint theorem, right? If we substitute the corresponding values now, we're gonna get 3 being equals to x of n, which is 7, plus x of p divided by 2. So if we cross multiply here, we're gonna get 6 being equals to 7 plus x of p. So minus 1 is equals to x of p, right? We can see that. Now let's find y of p, right? We're gonna exploit the coordinate m again. We're gonna say that y of m, if that's what we were looking for, we would say y of n plus y of p divided by 2, right? So if we substitute again, we're getting minus 5 is equals to minus 2 plus y of p divided by 2. If we cross multiply this, we should get minus 10 being equals to minus 2 plus y of p. So minus 8 is equals to y of p. So the coordinates of p is minus 1 and minus 8, right? And minus 8. Let's do 4.2.1. So 4.2 and then we have 4.2.1. So 4.2.1 is saying that let's determine the equation of the cycle in the form x minus a plus y minus b squared is equals to r squared. So here we're going to use the coordinates of m again, right? 3 will be a, and 3 will be a, and y will be b, right? Or minus 5. So if we put that into this equation, we shall get x minus 3, we have squared here, right? Squared plus y minus 5, so that will just be plus 5, right? Squared is equals to r squared, right? Now we have to find r squared. So to find r squared, we're just gonna take a point on the circumference of the circle and substitute into this equation, right? Or we can just determine the length of mn using the distance formula, but then let's just substitute it into the equation. So if we sub in n of coordinate 7 and minus 2, we're gonna get so what are we getting? 7 minus 3 squared plus y is minus 2, so we're gonna get minus 2 plus 5 squared being equals to r squared, right? So there we just have 4 squared plus what? I think that's supposed to be 3 plus 3 squared, so we have 25 being equals to r squared. So now our equation will be x minus 3 squared plus minus 3 squared plus y plus 5 squared being equals to 25, right? 4.2.2. So 4.2.2 is saying let's determine the equation of KL in the form y is equals to mx plus c. So let's look at KL. Is this line here, which is a tangent to the cycle, right? So we don't have the coordinates of k, we don't have the coordinates of l, but if we calculate the gradient of mn, then we're going to use that to find the gradient of KL, right? Let me show you what I'm talking about. So we're going to say that the gradient of mn multiplied by the gradient of KL should be equals to minus 1, right? Because the radius is perpendicular to the tangent, right? So if we make the gradient of KL the subject of the formula here, we're gonna get minus 1 divided by the gradient of mn, right? So the gradient of KL will be equals to minus 1 divided by y2 minus y1 divided by x2 minus x2 minus x1, right? Obviously you can do this separately. You calculate the gradient of mn separately, right? But then I'm just gonna put it all in at once and yeah, see what happens. So doing that, minus 1 divided by y2, so let's take n as the second coordinate, right? So that will be minus 2 minus 5, so that will be plus 5, and then divided by x2, so we have 7 minus 3, right? And then now let me just put that in my calculator real quick and see what I get. So I have 3 basically, and then divided by 4, right? So yeah, the gradient of KL is minus 4 divided by 3, right? So now we can say that y is equals to minus 4 divided by 3x plus c. Now we can sub in n, right, in order to find c. So if we sub in n, we're gonna get minus 2 being equals to minus 4 divided by 3 multiplied by 7 plus c, right? So c should be equals to minus 2 plus 4 divided by 3 multiplied by 7, and this should be equals to, so we have minus 2 plus 4 divided by 3 multiplied by 7, so c is 22 divided by 3, right? So y is equals to minus 4 divided by 3x plus 22 divided by 3. But then this equation looks shady, so let me just substitute the x value of n and see if I will get the y value, right? Perfect. I'm getting -2 when I substitute 7. So I think we're good to go. And then the follow-up question 4.3. So 4.3 is saying that for which values of k will y is equals to -4 divided by 3 x plus k be a secant to the circle. So a tangent touches the circle once, right? And then a secant, it goes through the circle. So this line here would be a secant. It's going through a circle. This line here would be a secant. It's going through a circle, going through a circle, going through a circle, going through a circle. So as long as the line is going through the circle, then it's a secant, right? But then, yeah, don't think this question was easy at all. But yeah, let me propose something here. The gradient of this line KL is equals to -4 divided by 3, right? And the line we are also interested in has a gradient of -4 divided by 3, right? So let me show you something. If we shift k some units, right, and then it's somewhere here, right, it still has the same gradient, right? Then it will be a secant to our circle, right? And then we can even put it here. It will be secant to the circle. We can put it here. It will be secant to the circle. We can put it here. It still is a secant to the circle because it's going through the circle, right? But then the only problem arises when it is somewhere here, when it touches the circle only once at P, right? Then it will no longer be a secant anymore. So as long as the y-intercept, right, the y-intercept is between the y-intercept of KL and the y-intercept when it touches the circle at P, then for those values of k, because k is the y-intercept, right, x is 0. So for those values of k, that equation will be a secant, right? So we need basically the upper limit and the lower limit, but we already have this value here, right? Because we know fully well that that value is from the line KL, right? And then that value is 22 divided by 3. So we already know what k should not be greater than. Now we only need what k shouldn't be less than, right? And in order to do that, we're going to substitute the values of p, right? So we're gonna say that y is equals to -4 divided by 3x plus k, obviously, right? And then we subbing in p, right? We know the coordinates of p, -1 and -8 from the above equations. So if we substitute p here, we're gonna get -8 being equals to -4 divided by 3, and then in place of x we have -1 plus k, right? So k will just be equals to -8 -4 divided by 3, basically, right? So k will be equals to -28 divided by 3. So when k is between 20 what, the y-intercept, 22 divided by 3 and -28 divided by 3, right? That line y is equals to -4 divided by 3x plus k is a secant to the cycle. Now let's do 4.4. So 4.4 is saying that we have points A of some coordinate T and T, and B that are not shown on the diagram, right? And then 4.4.1 is saying that so we are told that from point A, another tangent is drawn to touch the circle with center M at B, right? And then 4.4.1 is saying that let's show that the length of the tangent AB is equals to T squared, 2T squared, plus 4t plus 9, right? I would like to know how you guys solve this problem. So if you did solve it, please leave your solution on the comment section and I will pin the comment, right? But still, let's do 4.4.2, right? This is very similar to that question that was saying that let's find the minimum distance between f is equals to x squared, and that coordinate, I think it was like 10 and 2. But then anyway, so let's solve the problem we have. The problem here is in that let's determine the minimum length of AB. So we know that AB is equals to 2t squared plus 4t plus 9, right? So because we have a square root here, and I don't like dealing with square roots, I'm going to square both sides, right? So that I can easily digest the problem. So I will have AB squared being equals to 2t squared plus 4t plus 9. Since we're looking for the minimum length, I can derivate this and equate to the 0, right? Because let me show you something. This graph is going to be concave up, right? If it's concave up, then here at the turning point, we're going to have the minimum value, right? So we can derivate this and equate to 0, and then find the value of t of which we are going to have the minimum value, right? So if we do that, we're gonna get 2t squared. If we derivate in that, so we say in AB squared, we're finding the derivative of that, we're gonna get 4t plus 4 being equals to 0. So t here should be equals to minus 1. Let me show you something. Because we're basically looking for the x value of the turning point, right? We can also see that that x value t is equals to minus b divided by 2a, right? Because we just have a quadratic function. So this will be minus 4 divided by 2 multiplied by 2, which is equals to minus 1 again, right? So the distance, the length is at a minimum when t is equals to minus 1, right? But now let's substitute minus 1 into our equation and actually determine the minimum length, right? So the minimum length will be, so we have 2 multiplied by minus 1 squared plus 4 multiplied by minus 1 plus 9, right? So AB will be equals to so minus 1 squared, so we're just gonna get 2, and then minus 4 plus 9, so we have 2 minus 4, that should be minus 2, right, plus 9, so we have the square root of 7 basically as the minimum length of AB. Let's do 5.2. 5.2 determine the value of the following expression without using a calculator. So we have cos of 90 plus theta divided by sine of theta minus 180 degrees plus 3 sine of minus theta, right? So when I get a problem like this, I actually put it in the calculator first, right? So that I can get an answer, and instead of just solving, I'm now actually proving. So if you put this expression inside of a calculator, right? Instead of theta, you just put any number between 0 and 90, right? So you can put 3 here, right? If you do that, you're gonna find out that this thing will give you 1 divided by 4, right? So when you solve this problem, if you end up not getting 1 divided by 4, you have clearly done something wrong. We should get 1 divided by 4, right? So let's, go ahead and solve a problem and see what happens. So this will be equals to, so we have cos of 90 plus theta, right? So as soon as we see cos of 90 plus, right, we know that that's going to change to sine, right? Let's just put that in mind first. But then is cos positive or negative in the second quadrant? Because we have a 90 plus, right? So we move into the second quadrant. Cos is negative because cos is only positive on the first and on the fourth, right? So here we're gonna have minus, but cos is gonna change into sine. So we have minus sine of theta, right? And then divided by sine of theta minus 180 degrees. So sine of theta, we here in the first quadrant, right? because that is just theta. So if we minus 180 from theta, right, we're going to end up in the third quadrant, right? Why are we saying we're gonna end up in the third quadrant if you minus 180 from theta? Theta, it's a number between 0 and 90, right? If you minus 180 from a number between 0 and 90, your answer will be between 180 and 270, right? So sine of theta minus 180, we're gonna end up in the third quadrant, right? Is sine positive or negative in the third quadrant? Clearly, it is negative because sine is only positive on the first and the second, right? So here we're gonna have minus sine of theta, and then we have plus 3 sine of minus theta, right? So we can just pull the minus out there. If we pull the minus out, you're just gonna have minus 3 sine of theta, right? And there isn't much we can do there, right? We just have minus 3 sine of theta. So if we go ahead and solve this, we're gonna get minus sine of theta divided by minus sine of theta minus 3 sine of theta. So that will be minus 4 sine of theta, right? Sine of theta and sine of theta cancels out. So we just left with 1 divided by 4, like we had said that we're supposed to have. Yeah, now let's do 5.3. Let's do 5.3. So we have 5.3. So 5.3 saying that determine the general solution of the following equation. We have cos of x plus 2 sine of x multiplied by 3 sine of 2x minus 1 being equal to 0. So if you multiply in two numbers and you get in 0, then one between the two numbers must be 0, right? Like it's given. So now we can say that cos x plus 2 sine of x should at least be equal to 0, right? If it's not, then 3 sine of 2x minus 1 should be equal to 0. Yeah, 1 must be equal to 0, right? If we, take 2 sine of x to the right hand side, then we can divide both sides by cos of x and end up getting tan, right? So let's do that. If we do that, we're gonna get cos of x being equals to minus 2 sine of x, right? So if we divide both sides by cos, right, we're gonna get 1 being equals to minus 2 sine of x divided by cos of x. That will be tan of x, right? So minus 1 divided by 2 is equals to what? It's equals to tan of x, right? It's equals to tan of x. So let's note here that we're getting tan of x being negative, right? It's gonna be important as we solve our problem going further. Let's note that tan of x is negative, right? So we know that we're supposed to use the quadrants where tan of x is negative, right? So now we're gonna say x is equals to tan arc of. So here we're just going to use 1 divided by 2, right, without the negative sign. We're just going to use 1 divided by 2 without the negative sign, right? If we do that, we're gonna get 26.57 degrees, right? So yeah, now let's move to the other equation and solve that, and then when we get to this step, then yeah, we're gonna carry on. So if we solve that part of the equation, we're gonna get 3 sine of 2x being equals to 1. So sine of 2x is equals to 1 divided by 3. So 2x is equals to sine arc of 1 divided by 3. So let's note this again. We have 1 divided by 3, right? Which is positive. So we want quadrants where sine is positive in this part of the equation, right? Let's just take note of that. So if we say sine arc of 1 divided by 3, we're gonna get 2x being equals to, so we have 2x being equals to 19.47 degrees, right? So now, yeah, we are where we are. Let's go ahead and solve tan, right? So for tan, let's have our general solutions for tan, right? So we're gonna say that x is equals to, so one of our general solutions, right? One of our general solutions, x is equals to. So we're saying that we want quadrants where tan is negative, right? Tan is negative on the fourth and on the second, right? So let's start with the second. So what we're gonna do, we're gonna say on the second we have 180, right? So we're gonna say 180 minus the critical angle, which is 26.57, right? Plus k multiplied by the period of tan, which is 180, right? K being an element of integers, right? And then, yeah, now we have done the second quadrant. So we can say this is equals to, so 180 minus 26.57 will give us 153.43 plus k multiplied by 180, k being some integer, right? Being some integer of choice. And then the second general solution, x is equals to, so where is tan negative? Also, tan is also negative on the fourth quadrant, right? So we're gonna have 360 minus the critical angle, 26.57 plus k multiplied by 180, and then k being an element of some integer. So if we say 360 minus 26.57, we should get, what should we get? We should get 333.43 plus k multiplied by 180 period of tan, right? Where k is an element of integers, right? And then now we are done with that part. We can move to the part where we had the sign, right? So the general solution for that part where we had the sign, we're gonna have the first one, x being equals to, so look here, what we circled here, right? We want quadrants where sign is positive, right? This is not x here, it's supposed to be 2x. So we have 2x being equals to, so in the first quadrant, we just use the angle as it is, right? So here we're just gonna have, what do we have? 19, so we have 19.47 plus k multiplied by the period of sign, right? What is the period of sign? The period of sign is 360, so we have 360 k, an element of some integer, right? So what we want to do here, we have 2x, right? So we're going to divide throughout by 2 so that we can have the value of x. If we do that, we're going to get x being equals to, so 19.47 divided by 2 should be 9.735 plus k, and then 360 divided by 2, that should be 180, right? K is still an element of some integer, right? So that's one of the solutions. And then now let's move to the second quadrant, because sign is also positive there. If we move there, we're going to get 2x being equals to 180 minus the critical 19.47 plus k multiplied by 360, k being an element of some integer, right? And then so yeah, we can just divide by 2 throughout, right? Even though we still have 180 minus 19.47 there. So if we divide by 2 throughout, we're gonna get x being equals to, so we have 180 minus 19.47 divided by 2, which is giving me 80.265 plus k, 360 divided by 2, that's 180. And then we know that k is an element of some integer. Yeah, let's do 5.4 and 5.5 on a separate video, right? This one is already too long. Write down the period of G. What is the period? The period is the time it takes to complete one cycle. So let's go ahead and take a look at G. As you can see, from x is equals to 0 to x is equals to 180 degrees, we have one complete cycle. The graph completes itself once. So that is the period of G. It is 180 degrees. It takes 180 degrees for the graph to complete itself. And then 6.2.1, let's calculate the value of K. So let's go ahead and look at our graph. K is the y value of our coordinate A. A is the intersection between f of x and g of x. We have the equation of both. We can just go ahead and use the equation of f of x. F of x is equals to tan of x. So if we substitute x is equals to 60, we should have f of 60 being equals to tan of 60 degrees. If you put this in your calculator, you're going to get k is equals to square root of 3, of which in decimal it is equals to 1.73. This is the value of k. 6.2.2, let's go ahead and take a look. In 6.2.2, we're supposed to find the coordinates of B. Let's do some analysis. From B to A, the graph completes itself once. There is one cycle between A and B. And we know the period of G of x. So we can say that the x value at B will be equals to the x value at A minus 180 degrees. This is equals to minus 120 degrees. Yeah, this is because from B to A, it's 180 degrees. So to find the x coordinate of B, we can say 60 minus 180 degrees, which is equals to minus 120 degrees. That is the x coordinate of B. And then the y coordinate, A and B share the same y coordinate. So y of B is also equals to square root of 3. So the coordinates of B, minus 120 degrees and square root of 3. That is 6.2.2. Let's go ahead and take a look at 6.3. So in 6.3, we're supposed to write down the range of 2g of x. But before we can look at 2g of x, let's try determining the range of g of x. Right, g of x is equals to 2 sine of 2x. The range of sine of 2x is minus 1 to positive 1. But because we have this amplitude of 2 and not 1, like we usually do, the range of g of x is from minus 2 to positive 2. So if we're looking at the range of 2g of x, which will be equals to 4 sine of 2x, then the range y will be an element of minus 4 to positive 4. And this right here is the range of 2g of x. We just multiply in the range of g of x by 2. You can always use this technique with any other question that is looking for the range. You find the range for the whatever function you're given, and then if it is 3 multiplied by that function, then you just multiply the range by 3 in this variation. That is 6.3. Let's go ahead and take a look at 6.4. Right, 6.4. For which values of x will g of x plus 5 minus f of x plus 5 be less or equals to 0? So we have x plus 5 and x plus 5. But before we can determine that, let's instead determine g of x minus f of x being less or equals to 0. After we find the answer for g of x minus f of x being less or equals to 0, then we're going to be able to find g of x plus 5 minus f of x plus 5. If we take minus f of x to the right hand side, we're going to have g of x being less or equals to f of x. As you can see now, our question changes. It's now very clear. We're looking for the value of x for which f of x is greater or equals to g of x. So let's go ahead and take a look at our diagram and see where we have. We are looking for the values of x for which f of x is above g of x. But we have an interval between minus 90 and 0. So this is the only part we are interested in. Yeah, where is f of x above or equals to g of x in that interval? Well, from this point they intersect until x is equals to 0. Do you know the x values for this point where they intersect? Let's go ahead and see if we can deduce that. If you look at A, the x-coordinate of A is 60. The x-coordinate of this point where they intersect will be minus 60 degrees. Why are we saying that? Where is that coming from? Take a look at our graph. From minus 90 to 90, g of x completes itself. From minus 90 to 90, f of x completes itself. So this point where they touch, let's call this point A prime. It is just a reflection of this point A. That is why if the x value at A was 50, the x value at the point where they touch will be minus 50. So let's go ahead and write our solution. F of x is greater or equals to g of x when x is equals to minus 60 greater than until x is equals to 0. This is for g of x being greater or equals to f of x. But instead, what we have is g of x plus 5 being less or equals to f of x plus 5. So what does this x plus 5 do to a function? It shifts the function to the left. If it was minus, it will be shifting it to the right. So if you are at minus 60 and you shift 5 units to the left, then you will be at minus 65 degrees. And if you're at 0 and you shift 5 units to the left, that is minus 5 degrees. And this is the solution we are looking for. Right, this is just helping us get there. Okay, 6.5. Determine the values of p for which sine x multiplied by cos x is equals to p. We'll have exactly 2 real roots in the interval. X is an element of minus 180 degrees to 180 degrees. So we have sine of x multiplied by cos of x being equals to p. Well, usually these questions, they are all related to each other. What do we have from our previous solutions or from our question that is very close to sine of x cos of x? Well, it is the mere fact that sine of 2x is equals to 2 sine of x cos of x. So what we can do to this equation, we can say 2 sine of x multiplied by cos of x is equals to 2p. We are multiplying by 2 on both sides. Why are we multiplying by 2? So that we can change this term. 2 sine of 2x is equals to 2p. We know fully well that, let me show you. G of x is equals to 2 sine of 2x. So in order to get that, let's multiply out by 2 again. If we do that, we have 2 sine of 2x being equals to 4p. What is the maximum value of 2 sine 2x? Is 2 because of the amplitude. And the minimum value is minus 2. So we can say that 4p can be equals to 2. And 4p can also be equals to minus 2. We know that this is true at some point of time because 2 sine of 2x has a maximum of 2 and a minimum of minus 2. So p is equals to 1 divided by 2, or p is equals to minus 1 divided by 2. Determine the length of AD in terms of P. So let me just highlight AD here so that we can have a bit of clarity. So there's AD, right? And then we want AD in terms of P, right? If you look at this triangle here, you're going to see that BD has this length of 2P and AB has a length of square root of 5 P, right? So we can use that triangle ABD. It has the most information and it has our variable P that we're supposed to determine AD in terms of. So let's use triangle ADB to determine the length of AD. In triangle ADB, you will realize very quick here that this angle here is 90 degrees, right? And AD is actually the hypotenuse of that triangle. If it is the hypotenuse, then we can use the Pythagoras theorem, right? So we're gonna see that 7.1 we have AD squared, right? Hypotenuse squared will be equals to the other two sides squared, right? So BD squared. There we go. So we're gonna have AD squared being equals to, what is AB? AB is square root of 5 multiplied by P, right? Squared plus BD squared. What is BD? That is 2P, right? And then we square that. So AD squared will be equals to 5P squared plus 4P squared. Now it's easy to see that AD squared is equals to 9P squared, right? If you take square root on both sides, you're gonna get AD is equals to 3P, right? And just like that, we're done with that question. Now let's solve 7.2. 7.2 says that let's show that the length of CD, let's just highlight CD before we go any further, right? So we are interested in CD, right? Let's show that the length of CD is equals to 3P sine of x plus x divided by square root of 2 sine of x, right? So let's look at CD. So we have the length of AD, right? We're saying that it is 3P. And then we have CD. So if you look at triangle ACD here, you will realize that here we have x, here we have 45. So this angle here should be 180 minus 45 minus x, right? So we have two angles and one known side. We can use the sine rule, right? So let's try apply the sine rule and see what happens. So if we do that, we're gonna get sine of A divided by A. We are in triangle ACD there, right? Let's be very clear about that. Being equals to sine of B divided by B. So you take sine of an angle and on the denominator you put the side opposite that angle, right? So if we say sine of x here, then we're gonna put 3P as the denominator, right? So let's do that. We're gonna have sine of x divided by 3P, right? Because that is the length of AD. Being equals to, let's not forget our aim. We want to prove the length of CD, right? So we're gonna use this angle here, which is 180 minus 45 is 135. So the size of that angle is actually 135 minus x, right? So we're gonna have sine of 135 minus x divided by CD, right? The length we're interested in. But then now it gets a bit complicated. You will realize that here we actually have a compound angle, right? But then that shouldn't be a problem, because we know that if we have sine of A minus B, this will be equals to sine of A cos of B minus cos of A sine of B, right? So we can just use that formula there to get rid of sine of 135 minus x, right? Because we cannot determine that because we don't know what x is. So we're gonna have sine of x divided by 3p being equals to so that will be sine of 135 multiplied by cos of x minus cos of 135 multiplied by sine of x, and then everything divided by CD, right? So we have CD here. So sine of x divided by 3p will be equals to sine of 135. Sine of 135 is square root of 2 divided by 2, and then multiply by cos of x, right? We don't know x, so we cannot do anything to that. And then minus cos of 135. Cos of 135 is minus square root of 2 divided by 2. So this will just become plus square root of 2 divided by 2. And then sine of x is just sine of x, right? There's nothing more we can do there. Divided by CD, right? So sine of x divided by 3p will be equals to, obviously we're taking square root of 2 divided by 2 as a common factor, right? But then before we do that, we know fully well that square root of 2 divided by 2 is equals to 1 divided by square root of 2, right? You can actually prove this. Say square root of 2 divided by 2 minus 1 divided by square root of 2. You will get 0 because they are equals to each other, right? So instead of writing square root of 2 divided by 2, we can write 1 divided by square root of 2, right? And take that as a common factor instead. So we're going to have cos of x plus sine of x divided by CD, right? So this we can cross multiply here. If we cross multiply, we're gonna get sine of x multiplied by CD being equals to 3p multiplied by 1 divided by square root of 2 multiplied by cos of x plus sine of x, right? And then everything divided by no, we're not dividing yet. But now we can divide both sides by sine of x, right? If we go ahead and divide both sides by sine of x, then we're gonna have CD being equals to 3p multiplied by 1 divided by square root of 2 multiplied by cos of x plus sine of x divided by sine of x, right? But then instead of putting 1 divided by square root of 2 on the numerator, we can just write CD as 3p multiplied by cos of x plus sine of x divided by sine of x, and then multiplied by square root of 2. And we have proved exactly what we are supposed to prove. Now let's do the last question. 7.3 is saying to us, if it is further given that p is equals to 10, so p is equals to 10 and x is equals to 110 degrees, let's calculate the area of triangle ADC, right? The area of triangle ADC. Let me just erase a few stuff so that we can have a bit of clarity here. So we want triangle ADC. We are interested in triangle ADC, right? So when we want to find the area of a triangle, right, we say half side 1, side 2, and then sine of the angle the two sides sandwich, right? So in this question, we know the length of size AD, right? And we know the length of size CD. So we have to use this angle here that they sandwich, right? So if we do that, we're gonna get the area of that triangle being equals to a half and then 3p, right? AD, and then multiply by the other side CD, and then sine of 45 degrees, right? But we know what CD is, so let me just put what CD is there instead. So CD is 3p multiplied by sine of x plus cos of x, everything divided by square root of 2 sine of x, and multiply by sine of 45. We know what p is, right? P is 10, and we know that x is equals to 110. So we can just substitute 10 and 110 there, right? So that I don't waste time, I'm just gonna do it here already, right? So instead of p there, I'm going to put multiply by 10, right? Because p is 10. Here I'm also going to multiply 3 by 10. Instead of sine x and cos x, I'm just going to have sine of 110 plus cos of 110 divided by sine of 110, right? And then if you put this in your calculator, you should get 143.11 units squared. Always the center of the circle, M and PR, it's a cyclic quadrilateral, right? So let's just highlight M and PR. So we're saying that M
MNPR is a cyclic quadrilateral, and SN is the diameter. So we have SN is the diameter there, and then we have chord MS and radius OR, right? So let's jot down our keywords, right? We know that we can use the properties of a cyclic quad, right? And then what else do we have? We have diameter. We know that it subtends an angle of 90 degrees on the circumference of the circle. And then we have chord, right? Equal chords, subtend equal angles, and so on. And then we are told that M2 is equal to 64 degrees. I think now we can answer our question. 8.1.1 says that let's determine, given reasons, the size of the following angles. And then we start in with P, right? P is this angle here. But because we know that MNPR is a cyclic quad, then P plus M2 should be equals to 180 degrees, right? That's a property of a cyclic quad. So we have M2 plus P being equals to 180 degrees, right? Opposite angles of a cyclic quad sum up to 180, right? And then what is the size of M2? M2 is 64 degrees, and then plus P, which we're looking for, being equals to 180 degrees. So now it should be easy to see here that P is equals to 116 degrees, right? And then 8.1.2 is saying that let's determine the size of M1. So M1 is this angle here, right? So let's go to our keywords. We've used a cyclic quad already, and then M1 has nothing to do with the cyclic quad, right? So now let's use the keyword diameter, right? If we use the keyword diameter there, we'll see that M1 plus M2 should be equals to 90 degrees, right? Because they're being subtended by diameter Sn. So now we're saying that M1 plus M2 should be equals to 90 degrees, right? Why are we saying that it should be close to 90 degrees? Because it's being subtended by a diameter, right? So now we can say that M1 should be equals to 90 degrees minus 64 degrees, right? That is M2. So M1 should be equals to 26 degrees. And the last one, 8.1.3, we're looking for the size of O1, right? If we come to our keywords here, the only keyword that we have left is chord, right? But it won't help us with much. But what I want you to realize here is that O1 should be twice M1, right? We're saying that O1 here should be twice M1, right? Because an angle at the center of the circle is twice the angle at the circumference if they are from the same arc, right? You can see here that O1 is a consequence of SR here, and the same is true with M1, right? O1 is at the center and M1 is at the circumference. So now we can say that O1 is equals to 2 multiplied by M1. But what is M1? M1 is 26 degrees, right? So 2 multiplied by 26, that should be 52 degrees. So let's give a reason why DE is parallel to BH. So let me just highlight DE real quick. So we have DE here, and then BH is this line here. So we know fully well that if a line parallel to one side of a triangle, so this line DE here, if it's parallel to BG, then it should divide the other two sides proportionally, right? We can see here clearly that for 8.2.1, AD divided by DB should be equals to AE divided by EG, right? Because AD is equals to DB and AE is equals to EG. So we can conclude and say that DE is parallel to BH because it divides AB and AG proportionally. Now let's do 8.2.2. So 8.2.2 is saying that if it is further given that FC divided by BF is equals to 1 divided by 4, and that DE is equals to 3x minus 1 and GH is equals to x plus 1. Let's calculate, given reasons, the value of x, right? When you just look at DE is equals to 3x minus 1 and GH is equals to x plus 1, you can think the problems are really complicated, especially if you look at the sketch again and you look how it is. Yeah, you might get intimidated, and then you even see the mark allocation, 6 marks. But let's see what happens. So right now, we know that, let me just erase this line. So right now we know that FC divided by BF is equals to 1 divided by 4. And then we given DE, right? The length of DE in terms of variables. So we're given 3x plus 3x minus 1 there. So let me just write it down. We're given 3x minus 1 here. And then what else are we given? GH is x plus 1. So here we're given x plus 1. Okay, so now I see what's happening here. If DE, right? If this line here, DE, cuts AB and AG such that AD is equals to DB, right? You can see here, because of these lines that we given, that AD is equals to DB. If DE cuts AB such that AD is equals to DB, then we can say that BG is equals to 2 times BE. Right? DE will only cut AB and AG such that AD is equals to DB if DE is half of BG, or if BG is twice BE, right? So the reason we can give here for this statement here is that AD is equals to DB, right? This statement here is only true if AD is equals to DB. So if we say that, you will realize real quick that BG now becomes 2 multiplied by 3x minus 1, right? So now using that triangle BHC, we can say that in triangle BHC, we can say that, so what do we have? We can say that FC divided by BF should be equals to GH divided by BG. And why are we saying that? We're saying that because FG is parallel to CH, right? We can only see that if we have 2 parallel lines, right? So what is FC divided by BF is given to us. We have 1 divided by 4. But what is GH? GH is x plus 1, right? And then BG is 2 multiplied by 3x minus 1, which will just become 6x minus 2. Right? So now we are actually done with the conceptualization, right? We're just computing the value of x. So if we cross multiply here, we're going to get 6x minus 2 being equals to 4x plus 4. So it should be easy to see here that 2x will be equals to 6. So x should be equals to 3, right?
We need to prove that a line from the center that bisects the chord is perpendicular to the chord. We're going to do that in 3 easy steps, right? So step number 1 is to make some construction, right? So let's go ahead and construct OA and OB. Let me show you what I'm talking about. So we are going to join OA here. So let me just do that real quick, and then we're also going to join OB, right? And now we can move to the second step, right? So the second step, we're going to prove that triangle OAD and triangle OBD are congruent. How can we possibly do that? We can start by saying that OA is equals to OB. They're all radiuses, right? So they're supposed to be equals to each other. And then now we can say that OD is equals to OD in the 2 triangles because it's a common side, right? So our reason here will be common, is a common side. And lastly, we're going to say that AD is equals to DE DB, right? That's given. We can clearly see on our sketch that is given to us. So if those three sides are equal, we can then conclude that triangle OAD is congruent to triangle OBD. And why are we saying that? Side. All three sides are equals to each other. And now we can move to the last step. What do we know about perpendicular lines? We know that if two lines are perpendicular, then where they touch, they should make an angle of 90, right? So if we can prove that we have 90 right there, then beyond reasonable doubt, OD is perpendicular to AB. So let's call this angle here D1 and call this angle here D2 as part of our constructions. But we know that D1 is supposed to be equals to D2. Why am I saying that? Triangle OAD is congruent to triangle OBD, right? All corresponding angles should be equals to each other. So D1 should be equals to D2, right? But then it's easy to see that D1 plus D2 is equals to 180 degrees, right? As they are angles on a straight line. But D1 is equals to D2, so we can just say that 2D1 is equals to 180 degrees. So what are we saying? We're saying that D1 is equals to 90 degrees. So now we have proved that D1 is 90 degrees. We're gonna know fully well that consequently D2 is also equals to 90 degrees. Now we can conclude and say that OD and AB are perpendicular to each other because D1 is equals to 90 degrees, right? 9.2.1, let's prove that OTBG is a cyclic quad. So we're talking about OTBG. We need OTBG to be a cyclic quad, right? But then what does it mean when OTBG is a cyclic quad, right? That quadrilateral should fit on a circle, right? And then all the vertices must lie on the circumference of the circle. So we must be able to draw a circle, right? Obviously, I'm not going to do any justice drawing the circle, but we must be able to have something of this manner if OTBG is a cyclic quad, right? B is also lying on the cyclic quad. Yeah, that's what we mean when you say OTBG is a cyclic quad. So when I tried solving this problem, the mistake I made, I tried proving that it's a cyclic quad by saying that this angle here plus this angle here, they should be equals to 180. That is correct, right? And then another way I try to prove it is that this angle here should be equals to that angle there. And then I couldn't prove it using those two ways, right? I'm not saying those ways are not correct. They're correct, but when I try proving that OTBG is a cyclic quad using those ways, I couldn't, right? And then what helped is realizing that if OTBG is a cyclic quad, then this angle here, GBT, this angle GBT should be equal to the angle GTO, right? Why should they be equal to each other? Because they're being subtended by the same chord GO, right? So if we prove that those angles are equal to each other, then we have proved that OTBG is the cyclic quad. So let's go ahead and try that. So let me just erase this. So we are required to prove that angle GBO is equals to angle GTO. If we can prove that, then indeed OTBG is a cyclic quad, right? So let's go ahead and try and prove that. So very quick, you can see here that this line from the center is cutting the line EF in half, right? If it cuts the line EF in half, then this angle here should be 90 and this angle here should also be 90. So what are we saying? We're saying that GTO
GTO, yeah, that's correct, is equals to 90 degrees, right? The line from the center is bisecting the chord, right? So that angle there should be 90 degrees. So now we know fully well that GBO should also be 90 degrees. And indeed it is. We're going to say that GBO is equals to 90 degrees. Why are we saying GBO is equals to 90 degrees? Because this radius here will be perpendicular to the tangent, right? We know that fully well. So the radius is perpendicular to the tangent, right? So now we've proved that GTO is equals to GBO because they're all equals to 90 degrees, right? And then as a consequence, OTBG is a cyclic quad, right? It's a cyclic quad because clearly GBO and GTO are lying on the same segment. Now we can do 9.2.2 because we have proved beyond reasonable doubt that OTBG is a cyclic quad. So 9.2.2 is saying that let's prove that GOB. So let's just get rid of that. We have GOB here. So here's GOB. We're supposed to prove that apparently GOB is equals to angle S, right? But then immediately when you look at this, you would think that angle S is equals to angle STF, right? Because they are alternating. So let's just write that down. So we're saying that angle S is equals to angle STF because they are alternating angles, right? If you just look at that. But then if you look at STF, you will see that STF is equals to GTB, right? GTB. So we say that angle S is equals to, not angle S, but angle STF. So angle STF is equals to GTB because those are vertical opposite angles, right? Yeah, whatsoever the reason is. Yeah, we know that STF should be equals to GTB, right? But I kid you not, GTB should be equals to GOB, right? GTB is being subtended by GB, right? And then GOT is also being subtended by GB. We've proved that OTBG is a cyclic quad, so we can get away with saying that, right? So here we're gonna say that they've been subtended by the same chord, right? By the same chord. Yeah. So now you can see that we're saying that GOB is equals to GTB, and here we say that S is equals to STF. But STF is equals to GTB. So now we can say that angle S is equals to angle GOB. Why are we saying that? They are all equals to angle GTB. Let's see what's happening here. So in the diagram, PQRS is the cyclic quad. So let's indicate that, right? We have PQRS being a cyclic quad. I'm just going to write that down too. Because a cyclic quad is very important to us, right? There's a few properties around that. And then KP is a tangent, so let's have tangent there. And then what else do we have? We are told that CA is parallel to QS, so we have parallel lines. And then P1 is equals to R2, right? So what I've been proposing is that with only these 4 keywords, we should be able to, answer all these questions that we have, right? So let's go ahead and give it a try and see what happens. So the first question, 10.1, is saying that let's prove given reasons that S1 is equals to T2. And yeah, indeed, S1 is equals to T2. Let me show you how. So let's look at S1. S1 is here, right? is an exterior angle of a cyclic quad, right? We're using our first keyword there. So if it's an exterior angle of a cyclic quad, it should be equals to Q1 plus Q2, right? So S1 is equals to Q1 plus Q2, right? An exterior angle of a cyclic quad is equals to interior opposite, right? Yeah. So we've exhausted the cyclic quad. Now let's look at T2, right? Because we're supposed to prove that S1 is equals to T2. S1 has no immediate connection with T2, right? So let's try other ways here. When I look at T2, I realize very quick that T2 should be equals to R2 plus Q2, right? An exterior angle of a triangle is equals to the sum of the two interior opposite, right? So what are we saying here? We're saying that T2 will be equals to R2 plus Q2, an exterior angle of a triangle is equals to those two interior angles, right? So from here, where do we go? We can see that S1 is equals to Q1 plus Q2 and T2 is equals to R2 plus Q2, right? Let's go to our next keyword. We have the keyword tangent, right? Let's see what it can give us. So from the keyword tangent, we will see immediately that P1 here is supposed to be equals to Q1, right? P1 is supposed to be equals to Q1, right? Because of the turn chord theorem, right? Because of the turn chord theorem. So let's write it down. Let's say that P1 is equals to Q1 because of the turn chord theorem, right? So from here, what can we say? Let's look at the keywords again. With parallel lines, they won't give us much, but if you see here, we are told that P1 is equals to R2, right? P1 is equals to Q1, but then on the statement itself, we are told that P1 is equals to R2. So what does that tell us? That tells us that R2 is equals to Q1 because they are all equals to P1, right? So now you should be able to see here. Let me show you something. Now you should be able to see here that instead of R2, we can write Q1 because we have proved that R2 is equals to Q1 because they're all equals to P1. So instead of R2 plus Q2, we can say Q1 plus Q2, right? So now it will be easy to see here that S1 is Q1 plus Q2 and T2 is Q1 plus Q2. So we have proved that T2 is equals to S1 since they are all equals to Q1 plus Q2. And yeah, you get your 4 marks. And now let's move to 10.2. So we are at 10.2 now. So 10.2 is saying that let's prove given reasons that AD divided by AR is equals to AS divided by AC. So let's go and look at those lines and see what's happening, right? Are we going to use parallel lines or do we have to prove that certain triangles are similar to each other? Let's go to our sketch. Yeah, so we have AD. Where's AD? Yes, AD here, right? So AD divided by AR, right? Divided by AR is said to be equals to AS divided by AC. So we have AS here divided by AC, right? So I can see immediately here that this is all going on in true triangles, right? In triangle, not A, but triangle. In triangle ASD and triangle ACR. So if we can prove that triangle ACD and triangle ACR are similar to each other, then we can play around with their sides, right, and be able to prove that. So let's go ahead and prove that triangle ACD and triangle ACR are similar to each other. Even when you look at them, right, they do look similar. but you know, we have to prove we're not trusting our eyesight here. We actually have to prove that they're similar to each other. So real quick, you can see here that, let me just erase this line. So you can see here real quick, right, that A is a shared angle of the two triangles ASD and the triangle ACR, right? A is a common angle. So we can say that angle A is equals to angle A, obviously, right? This is a common angle, right? There isn't really much to say there. So from here, where do we go? Let's see. So here we are expecting angle S1 to be equals to angle C2, right? Because of just, you know, how the triangles are. So let's, you know, give it a look and see how we can potentially prove that. So we already know from 10.1 that S1 is equals to T2, right? But then, since these two lines here are parallel to each other, then T2 should be equals to C2, right? Because they are, is it called alternating, corresponding? I forgot the name, but it's called something. We know that C2 is equals to T2, right? And then you're gonna give that reason there. But you know what's going on. There's some reason there why T2 is equals to C2. It's because of the parallel lines for sure, but no, there's a specific reason why we say those are true. So now, since we've proved that T2 is equals to C2, we can conclude that D1 should be equals to R1. Why is D1 equals to R1? Because the third angle of triangles, right? If the other two angles are equals to each other, then consequently the third angle should be close to each other. So we've proved that ASD is similar to ACR, right? So let's look here. ASD is similar to ASR. So now we can say that AD, right, divided by AR is equals to AS divided by AC, right? We can only have those lines if we've proved that those two triangles are similar to each other. So what are we saying now? Now we're saying that AD divided by AR can be equals to AS divided by AC if and only if triangle ASD is similar to triangle ACR, and that's how we do 10.2, right? So now let's look at 10.3. So 10.3 say that let's prove that AC multiplied by CD is equals to AR multiplied by TC. In this question, I cannot see an immediate way why AC multiplied by CD should be equals to AR multiplied by TC. But you just wrote this paper today. If you have an idea, let me know in the comments.